let's talk a little bit about limits. So when we think about limits, this is a prime example. We'll just start with an example. So if I have some function f of x, and it's x cubed minus 1 divided by x minus 1. Let's discuss f's behavior near x equals 1. Now, we know from our study of pre-calculus and algebra 2 and whatnot that we can't just plug in 1 here because you'd get 0 on top, which is fine, but you get 0 on bottom. So we know that 1 is not in the domain of f. So since it's not in the domain, we can't just plug and get an answer. We have to think about this a little more carefully. And in your studies of pre-calculus, what you probably did was figure out a way to factor out and use those factors to reduce the problem, and then you could plug in. And that would actually work here. But we want to use this as an example of a relatively simple example to discuss the idea of a limit for things that you can't do that for. So if I want to graph this, I could graph this all day, right? I could, sketch it out, plug in points, use some techniques, and figure out the general behavior without having to plug in x equals 1. But let's take some points and kind of see if we can't work our way into 1, because it's defined everywhere else. So let's see if we can develop some intuition here. So if we come from the left, so that's sort of the term they usually say, from the left, meaning that the x values are working their way up to 1. When x is 0.75, we have 2.313, 2.710, 2.970. And if we got all the way to like 0.999, it would be like 2.997. If we come from the right, which is, again, these x values are larger and they work their way down, then we have 3.813, 3.310, 3.030, but we still don't know what goes there. But if you look here, if you take the average of each of those points, what you find is that the average, it's a little bigger than 3, very slightly bigger than 3, exactly 3. So what do you think that would be? And well, it turns out it's 3. And again, that's going to agree with what you might have learned in pre-calculus, where if you factor that out, you're going to get and that's that difference of cubes formula. They cancel. You have that. You plug in 1, you get 3. Right? Simple, easy peasy. But we're not always going to have something that simple. But regardless, this is a good way to get used to this. So we say that the limit as x approaches 1 of f of x is 3. And I'm going to write that out in the terms that you're going to be used to hearing. The limit of f of x as x approaches 1 is 3. And generally or generically speaking, we write about limits like this. We say the limit as x approaches a of f of x equals L. And so this is sort of a generic way. So instead of 1, we have some sort of a, and 3, we have some sort of L. And that's just sort of your generic thing. You can plug in A, you can plug in L to figure out what you're dealing with. And we're going to do some more, and we're going to learn some more rigorous techniques, but first it's important to get that intuition. If you don't know how to find a limit, take values that are near that point. Start plugging them in, graph the function, get some intuition about it, because while it's important that we get it the right mathematical way at the end, it's a lot more important if we understand what's going on as well.